Hi all, today we are going to discuss about introduction to transmission systems. So initially we know that the power can be generated using different procedures. The conventional procedures that are used are, first one is we can use the coal. So using coal, that power that is generated, we call it as a thermal power plant or thermal power. And the second one, this can be generated from the water will be stored and that potential energy will be converted to kinetic energy, thereby the power is produced, that is called as hydroelectric power. And then the third major source of power that can be done is using the nuclear energy, which is called as nuclear power plant. So this is the nuclear power plant. So then the fourth source that is commonly used is using the wind energy, so that is called as wind power plant. And a similar way, nowadays the recent trend is to go for the tidal power. So using the tides of the ocean we can generate, that is called as the tidal power plant. And similarly different types of other plants are there. This can be generated using diesel can be used, and similar way we can use the gas and etc. different sources of there. So now we can see the availability of the coal. Generally coal is available only in the coal mines. So if you want to generate the power where it is required, we have to transport from the coal mines to the place where we want to generate. Similar is the case the water cannot be transported. The power can be generated only where there is a river and there is a chance for construction of a dam for storage of the water. Similar is the case of nuclear power plant. Because of the security concern, whenever some emergency problem comes, there should be a chance to submerge this nuclear energy whatever is there. So some abundant amount of the water resources will be required if some emergency happens, like for example some issues we have seen in some countries. So that's why it is generally preferred to keep near to the oceans only. Then comes the wind energy. So wind energy will not be available where we want. It is mainly available in the areas of the coastal areas. So this can be generated in the coastal areas only. Similar is the case the tidal power. This can be used only in the coastal areas where the tides are more. So now coming to the diesel and gas, they are produced at different location, and where you want to generate you have to transport them. So first thing is that initially when the electric power is invented, so very few people used to use it. So as very few people are there, so what we used to do, we used to transmit the coal, diesel or gas, so they are transported to the user, and generally there is a generating station, and adjacent to the generating station there is a consumer. That means they used to generate where it is required and directly supply to the consumer. And generally initially when it is invented, the first voltage that is invented is a DC, and it used to operate at 110 volts DC. Now gradually the consumer started increasing because the power demand goes on increasing. So as the power demand increasing or the consumers are increasing, automatically generation capacity need to be increased. When the generation capacity is increased, we have to transport all these resources, so the cost for the transmission or transportation of these materials increases. And gradually as the generation is increased or the demand is increased, they have observed that the cost of transportation of fuel is much greater than the cost of the fuel itself in many cases. So the cost of the transportation is dominating. So they started searching for what is the alternative, what we can do. So they have decided it is much more economical. So wherever the coal mines are there, so let us assume the coal mines are there, here only we keep the generation. So this will be transmitted. So using the transmission lines, so this will be transmitted to the consumers wherever the consumers are there. Let us say for example, sometimes they can travel over 3000 kilometers or 4000 kilometers also. The advantage of this is here the transmission is done through the electrical system. The electrical system, the advantage is the losses are minimum. There is no transportation cost because the transportation cost of electrical transmission is much more less when compared to transporting the fuel itself. And some more advantages are, because if you are installing these generators, because generally the majority of the consumers will be near to the towns or the cities. So in the cities if you are installing the generating plants, so automatically the pollution increases drastically there. So that leads to problem in the towns. Let us take for example in the Delhi, the pollution is extremely high. So as the pollution is already extremely high, if you are generating that outskirts of the Delhi, then it will increase the pollution there. So what is the solution? Generate where the abundant value of the resources are available, like for Bihar or wherever the coal mines are available. From there we can transmit using the transmission lines. So the major purpose of this chapter is introduce to you what are the different systems of the generation, That means what are the different ways in which the power can be generated. So this power can be generated either in the AC form or in the DC, because there are two systems. Again in AC also there are multiple systems, DC also multiple systems. Then after deciding which system of transmission is used, then for transmitting, this transmission can be done in two ways. So one thing is using the overhead lines. So overhead lines, the conductor will be hanging. So second option is there, so underground cables. So out of these, which one will be the best? So these things we are going to see, and after that we are going to discuss. So in the transmission line, why different voltages are used, and what is the reason for going for high voltage transmission, and why there are subsystems, like there is primary transmission, secondary transmission, primary distribution, secondary distribution. Why those many things are there? That means we are going to discuss which system is best, what should be the ideal voltage for transmission, why there are different systems of the transmission, and out of the overhead and underground cables, which one to use in which case. So those things we are going to see as part of this chapter. So these various systems of transmission systems can be divided broadly into DC systems and AC systems. So again, coming to these DC systems, again DC systems can have, first one is DC two-wire. That means a generating plant will be there. Let us assume this is a generator. So it is having two wires. So this will be connected to load. This is DC two-wire system. Second one is DC two-wire system with the center or midpoint earth. So here I am writing on a glass screen, so the handwriting doesn't come properly. So I am providing the complete handwritten material in the description of this video. You can download the handwritten material from there. Here you try to understand the concept what I am teaching. So in this case, the two separate voltages will be there. So these voltages will be transmitted like this. This center point will be earth. That means it will be like minus plus, and this will be minus plus. So like this it will be transmitted. So here the voltage will be V, here voltage will be V. So the load will be connected here, or load can be even connected between phases if it is a balanced condition. Getting it? So your voltage at the load will be equal to 2 times of V1. Using this also you can transmit. So the third type of system is, if you want to connect for a single voltage, then some return conductor path is required. So for that purpose we can go for DC 3-wire system. In DC 3-wire system, one more wire is used. That is called as DC 3-wire system. Now coming to the AC systems, so there are different types. First one is the single phase system. So again in the single phase, the different types are there. The first one is single phase 2-wire system. It will be same thing like before. And the second one is single phase 2-wire system with midpoint earth. And the third one, the single phase 3-wire system. These are about single phase systems. We are going to see in detail in the coming classes. So here I am only briefly discussing about what are the things. So similarly we can go for the 2-phase AC system also instead of single phase. So again coming to the 2-phase, that is 2-phase 4-wire system. And the second one most commonly used is 2-phase 3-wire system. These are the famous systems in the 2-phase systems. So similarly we can go for the 3-phase AC systems. Again 3-phase AC systems, there are two types. One is 3-phase 3-wire system, and we can go for 3-phase 4-wire system. These are the different systems that are used. So now while deciding out of these systems which one we have to go, which one will be more economical, there are two parameters which should be discussed. So first one is, it depends on the two parameters, whether we are going for the transmission line, overhead transmission line, or whether we are going for the underground transmission line. So if you take that whether overhead or underground transmission line, the cost of transmission involves two things. The first one is the losses that occurs in the transmission line, and the second one is the capital cost. Second one is the capital cost. Generally the losses are very less because we design the system in such a way. The major investment will be the capital cost. So if you take a transmission line, the transmission line will have a tower. So here some insulators are there. So below this insulator the conductor will be hanging. So like this way the conductors will be kept. Insulators will be there. So the conductor will be laying like this. So what will be the cost of transmission line? Here tower will be there, and there will be some insulators, and there is conductors. Then followed by in between the substations, switch gear, all these things comes under the capital cost. Now coming to the cable, in the case of cable there will be a conductor. So there is a conductor. Above this you have to make some insulation to protect it from the surrounding conductors. Let us say for example I am taking a 3-core cable or a 3-phase cable. So this will be like this, a conductor will be there, above that insulation will be there. Above conductor will be there, above that insulation will be there. So this is my insulation. So again coming to the cable also same thing is there, insulation is 1. Then coming to the conductor, how much value of the amount of the conductor is required, and similar way how much value of the protection, size of the cable, laying it, maintenance, all these things comes under the capital cost. So we can summarize, out of the total cost we have to mainly concentrating on decreasing the capital cost, because if the capital cost is decreased, automatically the cost of transmission decreases. So let us take the consequences of different things. Let us assume if the size of the conductor is decreased. So when the size of the conductor is decreased, automatically I am discussing about the transmission lines first, overhead lines. So weight of the conductor decreases, volume of the conductor or weight of the conductor decreases. So when the volume or weight of the conductor decreases, automatically the cost of conductor is decreased. Agree with me? Now if the weight of the conductor is decreased, so this entire weight is falling on the tower. Everyone agree with me? So the strength of the tower that is required, so the tower strength that is required will decrease. So when the tower strength required is decreased, automatically the cost of the tower will decrease. So this also saves the power. So along with that, as the conductor size, because there is a concept called as the sag, that means between two towers. So if you take the conductor between two towers, so this, let us assume this wire is extending. So the wire we can see it will come like this. So this from the reference point in the center of these two towers, this is the gap. So this is called as the sag. So this sag depends on the weight of the conductor. We are going to discuss in the coming classes. So when the size of the conductor is decreased, automatically the sag decreases, because the amount of clearance required from the ground will mainly depend on what is the lowest point. From this point, this gives the clearance that is required from your ground. So as the sag is decreased, for a given clearance, automatically the height of the tower decreases. Or we can tell that the distance between towers can be increased. The distance between the towers can be increased. So I am just writing the formula for the sag. So sag will be equal to WL square divided by 8 into, so I think this is the weight of the conductor, WL square divided by 80 something will come. So the sag is directly proportional to the weight and directly proportional to the length between the length or distance between two towers. Agree with me? So if the weight is decreased, to produce the same value of the sag, I can increase my length between the towers. So that is the reason we go for the lesser value of size of the conductor. So this is the advantage. So summarizing all these things, we can tell that if I can decrease the size of my conductor, automatically the initial investment is decreasing drastically. So there is another option, because second parameter that decides will be the insulation. So the insulation depends on what is the voltage. So what is the economical value of the voltage and other things that we will discuss later on. Here we assume that the voltage produced is same in all the cases, and the electrical stress or the stress on the insulation is same in all the type of materials. So in that case we will compare these systems, and then we will proceed further in the coming topics. We will discuss about what will be the effect of the voltage. Now coming to the underground cables. Underground cables, there is no concept of tower or sag, but coming to underground cables, so there will be a conductor. Above this conductor there lies the dielectric material. So this thickness of this dielectric material, that means thickness means, let us assume the inner radius is R and the outer radius I am taking as capital R. So capital R minus small r, this will remain constant for a given voltage, because it should withstand the required dielectric strength. So now let us assume if the size of the conductor is decreased. When the size of the conductor is decreased, to maintain capital R minus small r is less, so automatically the radius decreases, outer radius. Okay, when the outer radius decreases, the volume of the insulating material required. So volume of insulating material required, because it depends on pi into capital R square minus, this means pi into capital R square minus pi into small r square multiplied by the length of the cable. This gives the volume of the whatever the value of the insulation that is required. So automatically as R is decreased, small r decreased, so automatically volume of the insulating material required will decrease, so automatically the cost decreases. And similar is the case for the conductor. As the thickness is less, the cost of the conductor also decreases. Not only this, the size, overall size of cable decreases. When the overall size of the cable is decreased, it will be very easy to lay on the below the ground. So these are the multiple advantages going for decreasing the conductor size or decreasing the volume of the conductor material required. So that's why we are going to compare different type of systems based on what is the maximum stress. The maximum stress is maintained constant or maximum stress is assumed to be same in all the systems, and then we compare. Again, while comparing, there is a difference between overhead systems and the underground systems. So first going to overhead systems. In the case of overhead transmission line, the tower will be there. So the tower is generally at the ground potential, and from the tower the insulators are kept, and from the insulator the conductor is laid. So you can see here, this is the insulation. The insulation, one point is at 0 potential and second point is the supply voltage. So now the amount of insulation between this will be between the conductor potential and the ground potential. That's why in the case of overhead transmission, the maximum voltage between conductor and earth is kept constant for comparison purpose. Now coming to underground cables. So for the case of underground cables, so the cable will be like this. There will be different conductors, 3 conductors, let us assume, because 3-phase system is used. Practically we are going to prove it why it is used. So now this is one conductor at some potential V1, this is another conductor at potential V2, this is at potential V3. Now potential difference between these two voltages decides what is the thickness of the insulation required or up to what value of the voltage we can increase. So the distance between two conductors are deciding, or the potential between two conductors decides the dielectric breakdown or how much value of the insulating material is required. That means we can tell that here for the case of underground cables, the maximum, the stress is called as a disruptive stress between two conductors is taken as reference or constant while calculating. So this is the difference between these two. So that means the analysis of overhead transmission line is different, the analysis of underground transmission line is different. So in tomorrow's class we are going to discuss about the comparison between different type of systems for overhead transmission line, and after that we will go for comparison of different systems for underground transmission lines or underground cables. I hope till now the basic concept of the transmission systems is clear to you. If you still have any queries, you can leave your comments in the comment section below. I will answer to your queries from there. Thank you very much.